The white-cheeked starling is rapidly increasing its numbers in urban areas. Slightly smaller than a pigeon, they stand out with their feet and beak, which are yellow with a tinge of orange. This starling lives all over Japan, building its nest near populated areas to avoid predators such as snakes, making it highly observable regardless of the season. The white-cheeked starling's diet consists of earthworms and other underground insects. Although once considered a beneficial bird as it ate insect pests that attack crops, excessive noise and droppings are becoming a problem due to their habit of creating a roost and gathering outside of the breeding season. It can be said that this mass roosting behavior is something found right across the Sternidae family of birds. This bird is the crested myna that inhabits southeastern China and Indochina. In recent years, it has begun breeding in western Japan's urban areas, causing the same noise and droppings-related problems as with the white-cheeked starling. While being an extremely annoying bird to have roosting nearby, this can also be looked upon as a precious opportunity to study this bird's population behavior in detail. White-cheeked starlings and crested mynas each have individual resting places in their roosts. And they have a habit of moving in unison with the birds around them when close to the roost or flying in a flock. This behavior is of great use when escaping the birds of prey that are their natural enemies. Should a single white-cheeked starling detect a threat and change course, the surrounding birds take the same evasive action, keeping their mutual spatial relationships and moving as though the flock was a single entity. It is possible to simulate this movement using 3 rules, namely, keep individual distances, match flying speed and direction, and maintain the group's formation. In recent years, analysis with this simulation has revealed that white-cheeked starlings seem to be matching the movements of the 7 birds immediately surrounding them. Sometimes exceeding 10,000 birds at a time, the mechanism by which white-cheeked starling flocks behave as if they were a single entity is expected to be applied to areas such as automated driving systems for cars and distribution systems. However, simultaneously processing the information from 7 movements is extremely difficult, even for modern computer systems. It appears that the white-cheeked starling not only adjusts its movements to match birds around it, but also uses some kind of sensor to realize this harmonious movement. The nature of this sensor is, for the moment, completely unknown. Humans do not have such refined sensors with which to measure the natural world. However, humankind possesses the power of analysis, one that goes beyond our natural limitations. The protection of this diverse and beautiful Earth through the analysis of nature is a mission that has been entrusted to humankind.